So we took a look at some of the variations of the equipment that you might see in a laboratory. So again, they come in all shapes, they come in all sizes. Some of them are prettier than others, but they all do the same job, right? So when it concerns a UV vis spectrometer, it just really depends on what you're using it for and how much money you want to spend on the piece of equipment to do its job. So, again, I want to talk some terminology about what this instrument is doing and what's going on inside of the instrument to make it work. So, first off, you need to understand that this machine uses light to measure samples with. Okay, so let me kind of give you a rough drawing of what's going on. So, we have a sample compartment. And this sample compartment is going to house, of course, some type of liquid on the inside. And we're going to put that inside of the machine. This machine uses a light bulb to do the measurements with. Okay? And this light bulb, because it is a spectrometer, right? A spectrometer is a meter that uses light to measure. So this light bulb is going to be aimed at the sample, and not all of the light will go through. Only a portion of the light will escape. So I'm going to draw this kind of a solid line, and we end up with the dotted line. And that light is measured by the eyeballs of the instrument that we call the detector. So this is my detector, this is my sample, and this is the light source that I'm using. All spectrometers are made the same way. It doesn't matter which they are. It could be a UV vis spectrometer, it could be an infrared spectrometer, it could be an atomic absorption spectrometer. It doesn't matter. They all use a light bulb, they shine it at a sample, the sample does something to the light, not all of it comes through, and the detector picks up how much is coming through. Okay, so overall picture, that is a very simplified version of what's happening inside of the instrument. The problem, though, is that you have to understand that not all samples are suitable for UV vis analysis. Some people believe that you can measure anything in a UV vis instrument, and that is not true. It is a false statement. Some compounds do not measure at all in a UV vis spectrometer. So because of that, we've got to use other equipment to measure those. A handful of different types of properties on compounds make them suitable for UV vis analysis, and we'll talk about them, not right now, but we'll eventually talk about them. But you need to understand that this is not a universal piece of equipment. It finds its place and it finds its home in certain fields of laboratory and research more than others. And that's due to the types of compounds that are associated with those fields. This is not a universal system. It doesn't see everything in a sample. And not only that, but it really loves pure compounds. It is very difficult to measure mixes. You do not want to measure mixes on a UV vis instrument. Now, we can do it. And actually, in our program, we have a laboratory that shows you how to do it. But the math that's associated with those particular types of measurements can become very complicated, and it's because it is matrix based. So if you've ever worked with matrices in math class, then you probably can associate those types of problems, mix it in with a little bit of chemistry and technology and ultraviolet visible spectrometry, and you can realize how complicated that this can get. So we really like pure compounds. That means in order to utilize a UV vis spectrometer, there's probably a sample that you are going to be using. The sample is going to have to be cleaned up. And then it's going to have to be a pure compound that you use on the machine. So there's probably going to be some type of an extraction process in here as well. So this extraction process could take a while. And it really depends on what types of samples that you're using. Quite honestly, that's what it all boils down to. So some of these extraction processes could take a matter of minutes. Some of the extraction processes could take a matter of days. And that's something that you want to look for. So if you are wanting to use UV Vis for a research project topic, or if you're trying to come up with an idea on how to use it to measure samples with, you need to keep that in mind. What is the sample preparation like to bring it to the point where you can run it on a UV Vis instrument? And this is one of the reasons that UV Vis is often coupled to something like HPLC. And the reason is because the HPLC is doing the extraction and the cleanup. You can also have this thing on an IC system. And we can have IC UV vises, and that's because the ion chromatograph does the separation. It does the cleanup for you, and you do not have to worry about it. So if you've had some previous experience with high performance liquid chromatography, you know what that does. It separates the pieces and the parts of the compounds or the samples that you're analyzing, and it gives you data on each and every component. Well, it's doing the work for you. That is why they began to couple these two instruments together. So if you're just running a UV Vis instrument though, only, and that is it, those are the things that you got to keep in mind. Samples have to be cleaned up. Samples have to be extracted. Only one component can be analyzed on the UV Vis instrument easily. So because of that, you're looking for pures. You're looking a process that will extract only one thing that you want to measure, and that thing only goes into the machine, and you pick up and you measure it and you do your data analysis with it. So that's the caveat. That's the drawback with the instrument. Some of these instruments, this would be called a single beam instrument. We also have a double beam instrument, and a double beam will take this light and it deflects it into a second beam, and this also would have a sample holder that I would put liquid in. Typically, one of these is a blank, so I'm going to write this as a DI water. And then it does the same thing, and then it goes back up into the detector. That is what we would call a double beam spectrometer. So there's a couple of those versions out there. What happens is that imagine you are using a balance. One of the very first things that you do to a balance is hit the tare button. You make the balance read 0. And then you can add your stuff and weigh it on how much you're adding, right? But you've got to hit the tare button to make the balance read 0 in the very beginning. The same way happens with instrumentation. With the instrumentation, you have to hit a tare button, and that makes the instrument read 0. Then you can put your sample in it, and then you can run your sample. Well, the double beam spectrometers, when you put your sample in, it will read the sample and it will tare itself at the same time. You no longer have to do it. It knows what to do on its own. So it saves you a little bit of time. So there are double beam spectrometers that are out there, and that's exactly what they do. For us, though, we have single beam spectrometers. So you're going to have to tare it or blank it on your own, and then you're going to have to insert your samples as a second step. We do not go through the thousands of dollars that are required to purchase double beam spectrometers with. So everything that we have is a single beam. Okay, so a little bit about the setup of the instrument. Light bulb shines on a sample. The sample does something to the light that hits it. A portion of that light escapes through. and then the detector tells me how much of that light did escape through. And I use that to do some data analysis with it. And again, we'll talk about that later on. So we're going to take this concept and we're going to go a little bit further with it in the next video. This machine is a little more complicated than that. Of course it would be. But this is kind of getting your feet wet before we dump you into the pool. So stay tuned, come back and watch me again, and look at my beautiful drawings and look at my wonderful handwriting.